Hello everybody, and welcome to Balluff, and also welcome to the Smart Automation and Monitoring System. My name is Stefan Langer, and in this session I would like to give you the first introduction about our new Smart Automation and Monitoring System, to give you the first insights about the functionalities or the benefits you can get out of this system. And in this session, we will start with a short introduction about the system in general. That will be a short presentation about all the functionalities and the philosophy behind this system. And after this short presentation, we will go into a live demonstration about the system. We will do a topology and have a deeper look at some of the functionalities and see how the configuration and parameterization will work in this system. The content or the focus in this session is definitely on the consistency and comprehensiveness of this system. So our intention is to show you that all the functionality you will see later on of the system will be comprehensive over all the components which belong to this system, and the parameterization and configuration is always the same, independent of what kind of component you are working with. So let's start with this first introduction, a short presentation about the system itself. The Smart Automation and Monitoring System is intended to help you to make your application more transparent, to generate much more additional information which helps you to react much faster to changes in the environment or in changes in the situation of your application. And that means this system is, of course, based on our already existing portfolio. You see that we already have a lot of components which can help you to build up your application, like sensor technology, like RFID technology, machine vision, human-machine interfaces like smart light indicators, for example. We have machine safety integrated into our portfolio, as well as industrial networking. And we can combine all these functionalities and components to system solutions. In addition, we have some helpful things like accessories, like mounting systems, connectivities, like all the cables, and of course, the power supplies in IP20 or IP67. And as I said, based on this already existing system, we created new components which will help you to, as I said, generate much more additional helpful condition monitoring information. And also to this system, we have as well the sensor technology, as well as RFID, human-machine interfaces, networking components, and so on. So the Smart Automation and Monitoring System is a combination of software and devices. So that means we implemented condition monitoring and advanced features into every single component. We will see later on what kind of components we have in this system. And this can help you to eliminate the downtime of your application by simplifying troubleshooting, of course, and also the changeover and the setup of the machines. The parts of the Smart Automation and Monitoring Systems, as I said, of course, are optoelectronics, inductives, capacitive sensors. We also have identification systems like RFID read-write heads in HF or UHF functionality, the I/O modules, the networking components, and also a software package to parameterize and configure all these components. Uniformly and comprehensive is the key of this system. That means independent of what kind of component you have, if it is a sensor or an RFID or networking or whatever, there is only one software package to configure and parameterize all the different components. That helps you, of course, to reduce the unplanned but also the planned downtimes in your machine and increase therefore the efficiency. That means less waste and more effectiveness. This is a portfolio we are talking about, and this is just the first step. So this is the beginning. In the future, we will have much more of these family members, let me say, much more of these components. But today, we will see our new networking modules like the IO-Link module, IO-Link master module, as well as IO-Link IO modules. We are talking about RFID systems in HF and UHF technology. We are going to have a gateway which we can use to transfer all these additional data, all these additional condition monitoring information to a higher level. Of course, we're talking also about sensor technology, inductives, capacitives, optical sensors, and so on. We have some quite new components like our digital position indicator, which can help you in format change applications, as well as our capacitive probe for level detection, for example. And we integrated some existing components as well. May you know already our smart light and also our condition monitoring sensor. Also, we have some accessories, as I already mentioned, like our cable spacer to help you to arrange your cables, especially in the washdown area, and as well in the washdown area, the plexiglass tubes for our safety light curtains, so that you can use also our safety solutions in washdown areas. Everything is combined, let me say, with our new software package, which is called the Balluff Engineering Tool. And you see a picture of this here in the upper right side. And that means all these components will be configured with only one software package, which is called the Balluff Engineering Tool. The values out of this is a lot. That means you will get out of the multi-functionality. That means all the components will have more functionalities beside their original task. Let me say, it's not only for a sensor to detect an object, it's much more. Yeah? And that means you can increase also the flexibility of your machine with this. Uniformity and simplicity means a reduction of complexity. You will see later on in the live session here that it's extremely simple to work and to configure all these additional functionalities. Analytics and diagnostics we integrated. That means a shorter time to market cycles and cost reduction, and also a process optimization, so that you can have a much faster diagnostic and you can react much faster to environmental changes, for example. Integration is also a big part. That will be maybe a topic of one of the next sessions, to see how easy it is to integrate the system into controller areas like PLCs, for example. Interoperability, I mentioned that before as well, is integrated here. That means the possibility to take all these additional information and move it up to the higher or to the next IT level, for example. That is also integrated into that system. Versatility means you will be able to adapt your application to lot size 1, for example. That means flexibility again. And comprehensiveness, that means all the functionalities are integrated in every single component. We will see that later on, how this looks like. This is how it is shaped or designed. Yeah, the uniformity and the multifunctionality, the versatility. Of course, this means all the additional data, all the additional information which are integrated into the components. It's not only the vibration alarm or the humidity alarm or an inclination information if a component is moved out of the original position, for example. It's also a configuration of the pins into every single component. You can select what kind of functionality and what kind of data, for example, you want to have on every single pin in these components. It is about logic functionality in these components, so you can combine these additional information to a new information. You can make logic connections in every single component, combine different information to a new set of information. Simple to integrate with our Balluff engineering tool. We will see that later on. This is the software package. The diagnosis, that means a uniform and comprehensive way of showing the status and the situation of every single component with, for example, LED diagnostics, but also in the software itself. And the interoperability, as an example here, is the JSON data format and the REST API, which is integrated into the IO-Link master module already. And the most important keyword for, of course, is the comprehensiveness. That means, again, all these topics here, everything you will find in all the components we combine to this smart automation and monitoring system. So independent, if it is opticals, inductives, identification systems, and so on, you will have all these functionalities in every single component. What does that mean in an application? So if you are using in your application opticals, inductive, capacitive sensors in different areas of your application, or maybe identification system to identify different tools you are working with RFID systems. If you have format change activities to do in your application, we can help you with the digital position indicator, which is this one, for example. Yeah. Or if it is I/O modules together to collect all these additional information, we are working with these networking or I/O modules. And we are going to use a gateway to transport these information to the next level. The additional data we are working with, the secondary information, which is integrated in every single component, we focused on the factors which can affect the efficiency of your machine. And from our point of view, these factors are, of course, vibration information, as well as temperature changes, humidity information, signal quality of every single component, inclination information, as I said, if a component moved out of the original position, and of course the LED diagnosis. This is what is integrated in the components, and we will see later on how this looks like. With a software package, you can transport these information to the next level and do your analytics or trends or whatever. That means in every single application, independent of what kind of component you are using, you can create your additional information. You can create warnings, for example, if a component is moving out of its position. You can create informations or warnings or alarms about a temperature change in a specific area, warning about the signal quality, the power supply, information about the lifetime. So we have a operating hour integrated, of course, in every single component, and warnings about humidity measurement, which is quite helpful in washdown areas, for example, and of course the very important topic, the vibration information. And that, again, independent of what kind of component you are using. And the idea is, if you want to have these kind of additional information, the status of the component itself or the status of the environmental situation, why not using the component you have to use anyhow in your area, because you have to detect something, you have to identify something, you have to measure something, whatever you have to do in the specific areas. Why not using this component to create or generate also these additional information? All these additional information you can get with a mobile device, for example, with a tablet, or you can transport this directly to the next level and do your analytics or diagnostics. That is the brief overview about the system itself. And now we want to go into the hardware configuration. And for this, first, I would like to introduce you our demo case. And in this demo case, we integrated, or we created a small topology, how it could look like also in your application. We have the PLC controller, which is here a Raspberry Pi, and connected to this via a network. We have the backbone, let me say, of our system, which is the IO-Link master module. Everything is based on the IO-Link technology, so every single component is coming with an IO-Link interface. Connected to this master are the different components. We have an optical sensor here. We have another optical sensor system here, the bullnose variant. We have an inductive M18 sensor here. We have the smart light connected, an IO module, and also an RFID read-write head with different tags. This is how a topology could look like, but to make it a little bit more real, let me say, we want to rebuild this kind of topology with my system here. So I would like to show you step by step how to connect the different components and how to create a topology out of this. So first, let's begin with the, as I said, the backbone of the system, which is the master module here. And to this master module, we are going to connect all these different components here on the table. First of all, we have to do is to connect the power supply. This is the first thing of uniformity. That means every connection is an M12 connector. Different coding, of course, yeah, but we are also now supplying the power to these systems with an M12 L-coded connector, which is this one, and this is what we want to do first. Second thing we are going to do is to connect the network, and this is the network cable which is connected to my PC, as well, of course, an M12 connector, and this is what we are connecting here. So after the power supply and the networking, we can continue with connecting the different devices. First device we are going to connect is this smart light. This is one type of the smart lights, and we will connect this with an M12 connector, 4 pins. Everything is an M12 connector with 4 pins, and on these pins it's always the same. It's on pin 1 and 3. It's the power supply, and pin 4 is always the communication. That means IO-Link. So we will connect the smart light to the first IO-Link port here. And then we go on with an RFID read-write head, for example, which is this one. This is one type of our RFID read-write heads in that system. You see here is a number of other RFID read-write heads in M30, M18, or M12 in HF or in UHF, different styles. We are using this. Next one is an optical sensor. This is an through beam sensor with red light. We will connect this to the next port. And you see As soon as it is connected, you will see that the power is provided from the port. Next one here, we can use the I/O module. This I/O module. This is a standard I/O module which is connected to an I/O link port, and on this I/O module you can connect standard sensor components. So you can also mix the high functionality components, let me say, with a standard component. This is a standard fork sensor, for example, or a standard inductive sensor, which is connected to this I/O module. Next one is an inductive sensor in M18 style. We can connect it to the next port. And another optical sensor here. This is a laser sensor, which we will connect to this port. Another inductive, this time in M12 housing. The other one was M18. And the last one will be a specific one. We are going to connect this sensor system with the emitter and receiver. This is an optical sensor, and the special thing is that we are not going to connect it directly, but with this inductive coupling system. So that means first we will connect this base unit of the inductive coupling system. And the device itself will be connected to the remote system, and we just have to put this into the working area. And then you see that with this contactless communication, you can connect every single device also to an I/O link port. And if I move out of this area, then connection is off, and move it to the area again, then it's on again. This is the receiver of this system, and the emitter of this system is also possible to use as an I/O link device, but all the ports are occupied right now, but it's also possible to use it as a standard component, so just to connect it to this I/O module, just to have the power supply. And you see that we have the power supply here, and now we can work with this system directly. Okay, so this is building up the topology, and now we are going to go into the software package to see how the configuration of this topology or of this system will look like. For this, we will open up our Balluff engineering tool, and the first thing we have to do in this Balluff engineering tool, of course, is to log in. And after logging in, we have the chance to do a scan of this topology here and to see what is connected. And if we do this scan, we can also switch on all the I/O link ports. That means it's not only the master module which is going to be scanned, but also the single ports, and we will check what devices are connected. If we do this, it takes a little time to check all the components, and after this we are going to get a list of all the detected components. Here we are already, and that means this is the list of all the detected components, all the components we already connected to this master module. You see that the first one here is the master itself, and then on the different ports we have the inductive sensors, we have the optical sensors, we have the laser sensor, we have the I/O module, the smart light, the RFID, and all these components. So everything is detected, and then we can select this and add this to our topology. And then it will look like this. And the first thing we can do is to arranged this a little bit so that we can that it's this a better overview. This is what is going to be automatically in the future, of course, but with this version of the software, we have to do it by ourselves, but it's only the first time we have to do it. You see that this is the inductive M12 sensor, which is connected to the master module. This is the emitter, the receiver of the optical system. This is the inductive M12 sensor. We have the first optical sensor here, the red light. We have the laser sensor here in this position. We have the smart light here, the I/O module. And the last one is the RFID read-write head. So this is a topology, and the first thing you can get is directly a kind of diagnostic out of this. If we just move out this optical sensor here with the inductive coupling system, and we check the device, we will see that this device is not longer connected. It's the same story when we, for example, disconnect this I/O module and check this as well. You will see that these two modules are not longer connected, so you can get directly a diagnostic information here in this overview. Of course, you can do also an automatic diagnostic so that it's doing this diagnostic all the time. If you select this update button here, then it's going to be automatically. Next thing we can do is to go into the I/O check. So this is to check if all the components are connected correctly and if all the signals are coming correctly. If we go into this area of the software, we will see again that it's a list of all the different components which are connected to this master module. And if we open up, for example, the process data, then we can read in this process data of the specific components. And if we just reading in something, you see that the values will change if we detect something or if there is no target detected. So this is one way to read in the process data, but you can also send out process data, for example, with this smart light here. And if you go to the output area and send out some process data, you can switch on the smart light directly out of the software. So that is to check if everything is connected in the right way. Change the color, or switch it off. So this is the first simple way to check if all the components are connected on the correct port and if all the signals are coming in the right way. But it's not that convenient, let me say. You can have a much better overview of all these signals if you go into the single components directly. If we start with the inductive sensor here, you see that if I select the component, the first thing which happens is that all the configuration parameters are going to be read in. And so it's an upload of all the parameters of this specific component. So we are in this inductive sensor here right now, and we see that the process data looks in this window much more convenient. So we see that if we detect something, we see that there is the switch point. The switch point here, the first one, you can see directly if the target is detected or not. And this is the first area you see that in these components of the smart automation and monitoring system, it's not only the switch point. It's not only the information of the detected target, we have a lot more of information. You see that there is an information about the signal quality, an information about the vibration alarm status. Yeah, so if we have a vibration situation in that area, we can read that out. We have an information about the inclination. You see, when I move this sensor, then the inclination information is going to change. So you can read that out as well. We will see later on how to work with this especially. What we also have is the vibration information like this, the RMS magnitude and also the peak-to-peak information. And this is if there is a vibration here in this area with this specific inductive sensor, we will get these information here as well. To make it complete, we also have the operating temperature, the operating hours, which can be set by the customer itself, or the total operating hours we have here, and the current operating hours. So these are the information which are available in the process data already in every single component. So we can check this with another component. Let's do it with this optical sensor, for example. And again, when I select one of these, then first thing which will happen is to upload all the existing parameters. So here we are. Again, first picture in this device is the identification. Yeah, that means the information about what kind of component is it. Is it a sensor? What kind of vendor information do I have? These are the standard information which are coming with every single IO-Link component. And then again, we can go into the process data, and we will see that also here we can use the process information. Oh, sorry. Okay, the process information, like the switch points, we have more than one switch point in this component, and we also have the measurement information, the deviation value. Again, you see, if I move this, yeah, then the deviation information is changing. We have the vibration information and all these things in the process data. If we are not sure with which component I'm working with, then we have the chance to identify or to find out where this component is located, and we call this the ping. That means if I want to configure this component, I can open up this component and go into the parameter, and then I have the ping information, and if I send this ping to this component, you see that there is a blue light flashing, and that means this is the ping answer of this device. That means, okay, here I am. Yeah, this is where I'm located. You have this functionality in all the different components. If we go to the optical sensor, for example, we will see the same structure. And again, this is the comprehensiveness. If you know one of the components, you know all the components. If you know how to work with the vibration and inclination and humidity and so on in an inductive sensor, you know it also for the opticals, RFIDs and so on. It's always the same. Again, we opened now this optical sensor here. We start with the identification. We have the process data. Again, we have the deviation value. We have the vibration information, and we have the parameter, we have the ping information. And if we do this, then we see, okay, now we are working with this component to identify this. So maybe we can stay a little bit here in this optical sensor to go a little bit deeper into how can I work with this information. We saw that we have inclination, that we have vibration information, that we have the process data and so on. And in this parameter area here, you can configure how you want to work with these kind of additional information. And if we go down in this parameter set, we see that we have one area which is called the inclination. And the first thing when we want to work with this is that we can set a reference orientation. This is a kind of teaching, yeah? And if I use this button here, then I teach this original position. That means this is the correct position of the sensor right now. And if I go to the process data again, we see that the deviation value is 0. That means correct position. And if I move this, then the deviation value will change. If I go back to the parameter again, to the inclination area, then I can activate the alarming of this as well. First thing I have to do is to enable the alarm and write that down to the component. Second thing is to set the threshold. That means up to which deviation value I would like to get an information. Let me say maybe if the inclination degree is over 5, for example, more than 5 degrees, yeah, then I will get an information. Then I will get an alarm, for example. This is the threshold, and I can write it down to the component. You can also read out all these information with acyclic communication, yeah, from a PLC, for example, or with a REST API from a higher level system. You can read out all these information directly as well, like this deviation value. If I read this, there is 0. And if I go to the process data again and move this a little bit, this sensor, we see that there is a deviation value more than 50. Go back into the parameter again and can read the deviation value here. You see it's 52. And then if I read out the status, then I get the information that the deviation status is bad. And this is a bit in the process data, of course. Well, so if I move back into the original position, you see now deviation value is 0 again. Go to the parameter again and read the deviation value. Deviation value is 0 again, so it's original position. If I read out now the status, then we see status is good again. That is the way how to configure all these information, all these functionalities, yeah, independent if it is a deviation or if we go further down into the vibration information, for example, yeah, you see that you have the vibration information here in X, Y, and Z direction. What is the actual situation here? And here you can again enable the alarm. You can set a threshold that you can say, okay, up to a certain level, the vibration in this area with this component is okay, but if it's going above this level, then I want to get an alarming. That is what you can do here. So the way of configuring this is always the same. Activating the alarm and then setting a threshold. And it's the same with operating temperature. It's the same with humidity. Every time you have to enable the alarm and set the threshold. And it is always the same in every single component. If we go back to the inductive sensor, for example, you see that in the parameter area as well, we have here the inclination area where you can set the orientation, enable the alarm, set the threshold. Vibration is the same, so it's always the same way, and it's always the same in every component. If you don't want to do this into this software here, you have also another chance to do this configuration, and you can do it directly in the web server of this master module. You can open the web server of this master module directly out of this engineering tool here, if you make a double click. So what we did is to open up the web server of this module, and you have again a kind of diagnostic information. So if we move out this sensor, you see directly that this sensor is not longer connected. And if we move this back again, then we'll see that the sensor is coming back and it's reconnected. So diagnostic also in this web server. But we have more diagnostic here in this web server. We have an area which is called the module health. If I go into that area, I have to log in again. Now I have to log in into this web server of this module. Last time we logged in into the Balluff engineering tool. And in this web server module health area, we see the first dashboards of the condition monitoring situation. And this is a dashboard or graphical information about the condition monitoring situation without doing any kind of software of screen building or something like that. Yeah, you don't have to create any visualization. Yeah, you have this everything integrated into the web server directly. We're starting with the condition monitoring information of the module itself, which is the system values like operating hours, like system uptime or boot cycles, internal temperature, and the power and current consumption. Yeah, these are the information you can find here. But that's not all. You also have the single information of every single connected component as well in this area. You have the boot cycle information, the operating hours, the system uptime, the port uptime, and also the signal quality of the port and also of the connected component directly integrated here into that window. And you can read out, by the way, every single value with REST API functionality, for example, or with acyclic communication with your PLC. Beside the system values, we have also the electrical values, and this is the current and the power on the different pins, on pin 1 and pin 2, and the total current and the total power. So the current and the power consumption of every single port. And this is not depending on an IO-Link component or something like that. You can do this also if the port is not configured as an IO-Link port. So if you just connect a standard component, you will get the same values. And last but not least, we have the environmental values. And here you have the internal temperature of the connected devices, the contact temperature, vibration, and the ambient pressure. And of course, you will see only values here if you connect components which are able to provide these components. So this is also an answer to the question, is it possible to mix this system also with other components which maybe are not coming from Balluff? Yeah, and the answer is yes, of course. You can combine this system with any kind of standard or IO-Link component. The only thing which can happen is that you don't get any values, any information here, but the functionality definitely is given. Okay, so at the end, I would like to give you a short outlook to the next sessions. And that means if we go back again into one of the components, you will see that there is a lot more information and functionalities you can use. And as I said, in one of the next sessions, we will go much more deeper into that direction as well. You have a short overview now about the system itself, a general impression about how to use it. And next time, we will go into the parameter area with these components and have a look, for example, to this specific area, which is called the logic blocks. You see that we can do logic connections in every single component. You can do and or NOR or XOR connections with internal information. Yeah, you can use here the different information which is available in this component, like pin 4 digital output, signal delay, system error, humidity information or vibration information. If you have this alarm set, for example, what we saw before, you can use these information and combine this with other information with logic connections and create the next information for the next higher level, for example. This is the logic functionality, which we'll have a look much more deeper in the next session. And we want to have a closer look to the pin configuration, for example. Here you see that you can configure the pin 4 and 2 as you want. You can change the functionality of the pin. You can create an analog output or a digital output, and depending on what you selected, you can choose if it is an analog output, for example, is it 4 to 20 milliamps, or with other components maybe 0 to 20 milliamps, and then what kind of signal I want to provide on this pin 2, for example. Yeah? So that means, again, the list of all the possible internal information, and you can use the easiest way is just to take the measurement signal and put it on pin 2. So a lot more functionalities, a lot more things to do in this system. And right now I would like to say thank you very much for your attention. I hope you enjoyed this session, and hope to see you again in one of the next sessions where we go much deeper into the system. Again, thank you very much.